Alright, so that last lesson we factored out GCF. We also factored trinomials who had a lead coefficient of 1, right? You just look for factors of C added to make B. So today we're going to add a little twist. That lead coefficient A is not going to be a 1. It's very similar how you factor it though. And we're also going to look at a few special cases that can make it a little simpler, certain situations. So here's some basic steps to factor a trinomial that does have a lead coefficient that's not 1. And I'd maybe just pause this video, encourage you to maybe write these steps down. We're going to look at some examples. So find the GCF. I would always look first of all, is there something I can factor out first that's going to give me smaller numbers to work with? So always look for that. And then here's what we do. Step 2, find factors product AC. So multiply that lead coefficient and the constant at the end. You want factors of that add up to make B. Notice that's pretty similar to what we did before, except it was just C that adds to make B. Now it's AC that adds to make B. Then we'll rewrite that middle term BX with the factors we found. Then we're going to group and find common factors, rewrite the expression. Okay, that may be a whirlwind. You may wonder what's going on. Let me show you some examples. Okay, let's go look at 4 examples on the next slide. So factor each of the following. Let me just grab a pen here. So we want to, nothing will come out of this, okay? So first we're going to multiply A times C. Well, that gives me 24. Let me just put it over here on the side. So I want factors of 24 that add to make 11. And again, you could start listing them if you need to, right? 1 and 24, 2 and 12, 3 and 8. Hey, 3 and 8 will work. And again, the more you do this, the quicker you can achieve that. Now here's the big step, okay? So 2x squared plus 3x plus 8x plus 12. Now I know they already showed this in the last lesson. I didn't show it in my video, but notice what I just did. 3 plus 8, 3x plus 8x is 11x. So all I did was rewrite this middle term as these two numbers, okay? And now I'm going to group. In fact, it helps maybe even just draw parentheses around these. What could I factor out of this? Think about GCF. Well, this first one I could take an x out is all. So that would leave 2x plus 3. And out of this next one, looks like I could pull a 4 out. So 4 times 2x plus 3. Now notice something. 2x plus 3, 2x plus 3. Hey, those match. So what if I factor that out? So I'd have 2x plus 3. And what's left behind? X plus 4. And again, you do a few of these, you could just write your answer from this step. You'll see what you're going, where you're going. But there's our answer, and again, we can multiply this together to check ourselves, but that's how we do it, okay? Let's try this one up here. Again, 6, 31, 35, nothing in common I could pull out. Now this is a little bigger. I chose this example on purpose. 6 times 35. Well, that's pretty big, right? 6 times 35. 2 times 35 would be 70, 3 times 70, so that's 210. So 210, we got a lot bigger number this time. So sometimes these will get up there. I'm going to bring a calculator up and just show you that I don't do all these in my head. We want two numbers that multiply to make 210 that are going to add to make 31. Now they're going to have to be negative. Okay, both of them will be negative since they multiply to make a positive. But I want two numbers multiply to make 35 and add to make 31. I don't have any idea right now what they are, okay? Maybe you can see it. So let's start testing stuff. 210, I know it's not going to be a real small number, so let me just start dividing. How about 210 divided by 5? Well, that's 42. Well, 5 and 42 don't make 31, do they? So how about 210 divided by 7? 30. 30 and 7 don't make 31, but we're getting closer, aren't we? How about 210 divided by 8? Doesn't work. 210 divided by 9? Doesn't work. 210 divided by 10? Oh, I made a mess there. Let me fix that. 210 divided by 10. Hey, 21. Oh, 21 times 10 would make 210, and 21 plus 10 would be 31. Oh, so maybe you could already see that one before, but I showed you how we could go through. So 21 and 10 will work, won't they? So same thing, we're going to rewrite. So 6x squared minus 21x minus 10x plus 35. Now notice, negative 21x minus 10x, negative 31. Now here's a question maybe some of you are thinking. What if I'd written 10 first? You know, does this order matter? Not really. Okay, very, very rarely, in fact, I don't know if ever, will it matter. So it'll work out. So now, just like we did, we're going to factor these. Now I'm going to do this. I'm going to put a plus there, put a little negative inside there. You'll see why. What could I factor out? Well, I could take a 3x. So 3x, that's going to leave 2x minus 7, right? Now what could I, and here's why I put the negative inside. I could pull out a negative 5, it looks like. So negative 5, and that would leave 2x minus 7. By the way, you know you're doing this right if these match. If they don't, you probably want to reevaluate, okay? Can you see the final answer? 2x minus 7 times 3x minus 5. There we go, okay? How about something like this? You see in the pattern? I'd encourage you maybe pause this, give this a try real quick. So we've got 36, we want them to add up, make negative 16. Now they're going to be opposite in signs, and so negative 36, let's see, we could do negative 18 and positive 2 would work for us. And so 3x squared minus 18x plus 2x minus 12. And I'm going to factor these. 3x, x minus 6, plus 2 times x minus 6. So notice I've got x minus 6, 3x plus 2. If you say, wow, we did that fast. Well, I've had a lot of practice. Okay. And one last one. Now, here's one I threw in here on purpose. Hey, these do have something in common. I could take a 2 out of all those. So let's do that first of all, okay? So 2, that leaves 9x squared plus 12x minus 5. Now I've got smaller numbers to work with. Now I'm going to factor this just the same way. Just ignore that 2. It's in our final answer. So 9 times negative 5. So I've got negative 45 out here. Well, factors of 45 add up to 12. So how about 15 and negative 3, right? So I basically have, again, I've got my 2 out front. Let me just go ahead and show that. And now I've got 9x squared plus 15x minus 3x minus 5. Again, 15x minus 3x adds to that 12. Now I'm going to group this guy. I'm going to group that. What could we factor out? Let me just do it underneath here. So I could take a 3x out of this, and that leaves 3x plus 5. I could take a negative out of this, so just a negative 1 basically, which leaves 3x plus 5. Can you see we're doing the matches? And so I've got my 2 out front. I've got 3x plus 5 and 3x minus 1. Okay, again, takes practice like anything. Just trying to show you a few. Let's look at some special patterns. Now, perfect square trinomials, differences of two squares. You don't need to know these, by the way, to be able to factor. All of these will factor doing exactly what I just showed you, but sometimes just understanding a couple patterns can help make it simpler. For example, look at this guy. If I multiply 25 and 81, that's a big old honking number. You could do it, you could pull out your calculator, you could start going through, but recognize something. 25, hey, that's a perfect square. That's 5 times 5. 81, that's a perfect square. 9 times 9. Well, 5 times 9 is 45, and if you double that, you get 90. So, this factors really nicely. It's 5x plus 9 times 5x plus 9. Or, we could just write it as 5x plus 9 squared, because it's a nice perfect square. See how quick I could do that? Because I recognized a pattern there. So that's, if you get big numbers especially, I would always look, are these perfect squares? How about this one? 9, 49, well, 3 and 7, right? Will it work? 3 times 7 is 21. Double it, you get 42. Now it's negative in the middle, so it's just going to have to be negative. So this is 3x minus 7 squared. Hey, look how quick that is. Now, how about these guys? Sometimes these look intimidating. Wait, they only have 2 terms. Where's that middle term? Well, they're even easier, okay, because they're a difference of two squares. Notice 3 and a 2 there. 3 squared is 9, 2 squared. So there's no middle term though. So I basically want two numbers that multiply together but add to make 0. Well, they just have opposite signs. And so this is 3x minus 2 times 3x plus 2. Notice what happens, you multiply that out, 9x squared, negative 6x plus 6x goes away, negative 2 times 2, negative 4. Ooh, those are nice and quick. I like those. Okay, how about this guy? See it? 4 and a 5. So it's 4x minus 5 times 4x plus 5. So again, once you start to recognize a few patterns, you can really knock some of these out. Again, I know I did that quick. This is just to introduce you. You're going to go through the lesson. You're going to get lots of practice. Okay, so take your time going through. Really try to understand these patterns and get a good feel for this.